Alright, so this video here will be about chemical formulas, counting atoms, and finding the mass of those compounds. We're going to start with something really simple. We're going to start over here with H2O. Alright, so in H2O the question is, how many atoms do we have total? This is just like math. It tells us exactly. It's almost like having, 2x plus y. Something like that is what this is saying here. So we've got 2 hydrogens and 1 oxygen. So that means that we have a total, sorry about that, we've got a total of 3 atoms. Okay. Now, how many elements do we have? We've got hydrogen, we've got oxygen. So we've got 2 elements. Now, if we want to find the mass of that, we say, okay, so hydrogen's mass equals 1. Oxygen's mass, if we come down here, we know it equals 16. And we've got 2 of these hydrogens, so that will equal 2. This still equals 16. So that will be 18 AMU. That's the mass of H2O. That's how much one molecule of water weighs. Okay? Let's try the next one. We're going to go up in increasing order of difficulty here. So 2H2O. Seems pretty simple too. We'll start up here. 2H2O. So remember, the little 'two's here, like this little one, which is a subscript, is just talking about how many hydrogen atoms are in this molecule. We know that there's 2 hydrogens in each water molecule. This big 2 out here, you need to pretend like there's a parentheses around this, like you're doing PEMDAS in math. So you're applying this 2 to both of these atoms. What that's saying is you've got a water molecule and another water molecule. So you can say, okay, so how many hydrogens do we have? We've got 4 hydrogens. How many oxygens do we have? 2 times oxygen. We've got 2. So 2 atoms and 4 atoms makes a total of 6 atoms. How many elements do we have? It's still just hydrogen and oxygen, so it's still just 2 elements. If we're going to find the mass of this, we can do it the same way. For hydrogen, we know that there's 4 of them, and they each weigh 1, so that'll equal 4. For oxygen, there's 2 of them, and they still weigh 16 each, so that'll be 32, for a total of 36 AMU. That would be the mass. Okay? So this works very similarly. If we, get rid of all this, if we say that there's 8 H2Os, that just means that I would draw H2O, 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 that's what, 5, 6, 7, 8. So now we're starting to get to not even a drop of water, right? Because even a drop of water has thousands, if not millions, of water molecules. But now we've got 8 water molecules. So that's all that means. So you can do that in one of 2 ways. You can just figure out what one molecule is, right? You can say, okay, so with the hydrogens, we've got 2. With the oxygens, we've got 1. So that makes a total of 3. Then you could multiply that by 8 to get 24 atoms. Or you could actually do your math out and say, actually, we have, 8 times the 2 would be 16, 8 times that, 8 times the 1 oxygen will be 8, and do your math that way. Oh, look at that. It still works out to 24 atoms. Either way you want to do the math is fine. You just got to remember that this little 2 is just referring to the H here, but this big number outside is applying to this, and it's applying to this. It's multiplication, PEMDAS. Let's take a look. Now we're going to slow down a little bit and do some of these bigger, harder ones. Alright, so we've got Fe. What's Fe? Fe is iron. Actually, I don't have iron on this periodic table, so we're going to skip that one just because I don't have it on the periodic table here in front of me. But we've got 3 H2SO4. Alright, So again, we need to remember that this 2 applies just to that H, and this 4 applies just to that O. This 3, however, if we have our parentheses, comes here, it'll come here, and it'll come over here. So we're going to solve this in the 2 ways we know how. Option A is the way that I've always done it. So we're going to say H, we're going to say S, and we're going to say O. So we start here with 2 hydrogens, multiply that by 3, and we've got 6. We start here with just 1 sulfur, so multiply that by 3, and it's 3. Start with 4 oxygens multiplied by 3, and that's 12. So that makes a total of 12 plus 6 is 18, plus 3 is 21 atoms. To find the mass of that, we've got 6 hydrogen atoms. We know that hydrogen weighs 1. Sulfur, on the other hand, we can look up. It's down here. It's got a mass of 32 AMU. And oxygen is 12 atoms, rather, and it weighs a mass of 16 AMU. So, I don't expect you to necessarily be able to do all that in your head. I've got my calculator here. 6 times 1, I don't need a calculator for that. 6. 3 times 32, that we can actually do in our head as well. That's 96. And if we've got 12 times 16, that makes 192. Add all these together. We come up with an AMU of 294. So that's the mass of that entire molecule. Okay. The other way to do it is option B. You say, okay, let's just solve for, we've got 3H2SO4. I'm going to rewrite it so that it's, a little bit neater. Let's just solve for what's in the parentheses. So hydrogen, we've got 2 of them. Sulfur, we've got 1 of them. Oxygen, we've got 4 of them. Right? We can total that out to find out how many atoms in just one. That'll be 4, 5, 7. And if we want to find total, we can now multiply it by 3, and that equals 21 atoms. We can then say 2 times 1 AMU. Sulfur is 32. This is 16. And we can say, okay, this will be 2. That'll be 32. So 16 times 4, that'll be 32 plus 32 is 64. Now, we add all of these 3 up. I'm going to move that down here. Sorry, we're getting a little crunch for space. 64 plus 32 is 96. 98 AMU is how much one molecule would weigh. Multiply that by 3, and we end up with 294 AMU. If you want to do that, that's fine. I like option A because that way I'm never forgetting about this 3. In option B, you're still doing the same math and you're still coming up with the same answer, which is perfectly fine. However, we want to make sure that when we're doing this, we are not going to forget about this 3, because here we're talking about 2, 32, and 64, but we need to remember that that's the mass of just this one compound, not this compound times 3. If you're forgetful like me, do it this way. That way it keeps the 3 there the whole time. So I hope this helps you figure out how to count atoms, how to know the number of elements, and be able to then figure out the mass of an entire compound.